Welcome, everyone. I'm Jeremy Bartley, Program Manager for ArcGIS Online and our JavaScript API. And this is the first time we've given this talk, so we'll see how it goes. I think we'll see how it goes, that's all I'll say. I'm here with a group of people. Introduce yourself, Paul.
My name is Paul Barker. I work on the online team, run the hosted feature services, arcade, view layers, a bunch of other stuff.
My name's Russ Roberts. I also work on the online team as a product engineer. I work on scene layers, scene viewer, host elevation layers, so kind of 3D stuff.
And I'm Kelly Giroux Wilcox, and I'm a product manager on the ArcGIS Online team. So I work with customers like you, and talking with guys like this.
And gals. We have gals, too.
Oh, yeah, gals too. So, guys and gals.
All right. So we're going to just go over the basic layer types and maybe give a brief background on what those layers are, and then give you tips along the way how you can make your web maps faster. We'll talk about some best practices and close with a little bit of making the right choices. So in the WebGIS, there's a number of different layer types, and actually, I rewrote the slide like 8 times, and I listed all of them, but it's like so overwhelming. So there is a lot of different layer types that are supported. I'm talking about the web map and the web scene. But the main thing is if we were to look at the highest level, we have feature layers. Those are layers that bring features from a feature service or a map service down to the browser and then render. Those feature layers are all rendering dynamically on the client, and there are several different sources besides feature service. We also have feature collections, streaming feature layers, which can be powered by stream service, WFS. But that's sort of the key components right there. Then we have raster tile layers. That brings down an image, a tiled image, or bunch of little tiled images, and displays them in the browser. The OGC version, that's WMTS. We also have a web tiled layer, so something that if you just have tiles on a web server to go and grab. Vector tile layers, very similar to raster, except instead of being pixels, it's actually graphics. And the graphics have rendering rules or colors associated with each individual graphic. Scene layers are a type of visualization cache for 3D, and Russ will talk about that. Map image layers, that's where you ask an ArcGIS server, hey, draw me an image for this screen, and then we get back the image and then draw it on the computer in the browser. WMS is the OGC version of that. And then we have imagery layers. That's powered by an image server, and it's very similar to the map image layer. We ask for an image, it renders it on the server, and then delivers it back. It's actually quite a complex set of layers, and thinking about how they generate the information to be able to display. That all has wildly different consequences on the performance of your map. So hopefully this session will illuminate some of this. We won't talk too much about map image layers or imagery layers, but yeah. Okay, drill into feature layers. First off, we have hosted feature layers in online or in enterprise portal. It supports editing, visualization. You can use it as input for analysis. Supports creating feature layer views that allow you to create different layers based on that source data from the same data set. How many people know about feature layer views? Okay, not that many. Feature layer views are very powerful, and we'll drill into that in a little bit. These are hosted in online or enterprise, and you can use this as a source for many other layer types. So you can create tile layers, scene layers, and so on. We also have feature layers that work directly with features hosted in an ArcGIS server. Could be an ArcGIS server feature service, could be a layer in an ArcGIS server map service. Very similar to online hosted feature layers. The biggest difference is that the online hosted feature layers move at a more rapid pace in terms of the evolution, whereas it takes longer for the enterprise hosted feature layers to move. And the only reason we say that is because we have more features and more capabilities to make hosted feature layers perform better in online than is available in enterprise right now. Enterprise team is consistently working to catch up. And then we have feature collections. These are, you can think of these as by value feature layers. When we say by value, we mean that it comes directly to the map as a set of JSON and is rendered right there. It only lives in the map or it lives in an item in online. It's really only appropriate for small data sets. And somewhere, around 4,000 features or less. If you, in the map viewer, either in enterprise or online, if you load a shapefile or you drag like a CSV on into the map, you end up with this feature collection and it's stored directly in the web map. The new map viewer won't have this dead end experience that we have in the current one because a lot of times you have bigger data and then you think, oh, that's as big as we can load. Well, no, you can load as Paul was just showing me how big was that?
700,000. But
what was the size of that file?
the feature service, 23 gigs.
He was just showing me a 23 gigabyte feature service that he's loaded in online. But in the map viewer itself, once you bring a file in, either by dragging and dropping or uploading a file from your desktop in the map viewer, you are going to be limited to the number of features that you can have. If you publish from content page, then you're unlimited, like Paul just said.
Jeremy, question on feature collections. Is that strictly points or can you include polygon data?
Feature collections can include points, lines, or polygons.
From a CSV file?
A CSV file will generate a point feature collection, but if you upload a shapefile in the map viewer, that'll generate a line or a polygon, depending on what the shapefile has. Back 2 years ago, when online was still working out the best way to scale our feature service implementation for data that changed a lot, changed very frequently, and had very high views. So something that went viral, something that went to the public, like let's say Texas DOT road conditions. Feature services didn't work for them at that time, and they had to go to this feature collection route. That was easily scalable for us, and that was their path forward. Fast forward 2 years, or even into last year, we'd made such improvements in our hosted feature layers in terms of scaling and handling extremely high viral loads, and the ability to update and keep things live and fresh, that they don't have to do that anymore. So hopefully feature collections will fade away. The hosted feature layer, that's the bread and butter and the starting point of the WebGIS. It's flexible, fast, and supports editing, can be used offline, supports changes. It's used offline and the changes are synchronized. You can publish from many different sources. It's used across the platform, multiple ways to download. This is an old slide. We have,
Wait for it.
3.1 million hosted feature services in online. And that number there is probably wrong too, 5,000 to 7,000.
Probably bigger now.
Yeah.
You guys are publishing a lot of feature services.
One of the fastest growing items in online. And just to get back on the scaling, we scale very well. So even this week, we have very large things happen, where we have things that are causing extreme not load on the system. So we have fires in California and the western U.S. We have the Tour de France. These are all maps that go viral with lots of people, lots of eyeballs, lots of people looking at them, and we handle that very well now.
Jeremy, what is the upper limit on feature, custom feature layers? Like, can I have a parcel map service, say with 1.6 million parcels, upload that as a custom feature?
It's a great question. The question was, how big can feature services get? I know for a fact that there's a 95 million record parcel layer that's being tested out at the moment. So they can get pretty big. At that point, you do need to exercise a lot of these strategies that we're going to show you today to make sure that you get a great experience. But yeah, they can get pretty big.
You can't draw all.
Yeah, obviously you can't draw all 95 million, but
the other thing that slightly a tangent here, but online was just updated last couple weeks ago, and we changed the way that we upload files to online. So we used to have a 1 gigabyte file limit when uploading in the browser. If you had anything bigger than that, you had to go to Pro and upload using the packaging tools in Pro. Now the browser limit is 200 gigabytes, and it loads much faster. So for example, a 80 megabyte file that I tested with before the upgrade would take 120 seconds to load. After the upgrade, it takes 11 seconds to upload into online. So significant improvements. So where we're at now is that loading from the browser is as fast, or in some cases faster than using Pro to load into online. So I think that's exciting. Sorry, tangent. Hosted feature layer views allow you to create new views of your data without duplicating any of the source information. It's very much like a database view. So a database view that you might work with your DBA, or if you know SQL you would create, creates another look into that layer, into that table. And you can have as many of those as you want, and you've got one source data set. And online, now you can create these feature layer views, and it's much the same way, except you don't have to know the SQL how to create it. We'll create it for you. And it allows you to tailor the capabilities of the feature service for your audience. So you can remove sensitive information, change how you access the sharing properties of the layer, or the editing properties. Enterprise 10.6 has view support, and it's the same capabilities of the feature layer. Probably the most important thing in terms of a performance aspect is you can greatly improve the performance of your feature layer if you remove the attributes that you aren't using. So what do I mean by that? Here's a map of, I think this is like 3,500 city metropolitan areas. So it actually is a polygon. So if I zoom way in here. So this big purple one here is this outline. There we got little cities, Fillmore, Santa Paula, the Riverside, San Bernardino area. And I enriched this layer with information from the Living Atlas. Oops, sorry. And I created a map that shows me the predominant city education level. So areas in yellow, or cities in yellow, the predominant education level is never even went to high school. Areas in turquoise here are high school graduation is the most common type of education. This is based on 2015 data, so a little bit older. And if you look at the red ones, those are colleges. Now, if I open this table again, I've got a lot of attributes. So I enriched a lot of data into this. Anybody have layers like this where you just got tons of stuff? Yep. Well, that all adds up in terms of the amount of data that's transported to the client. On the JavaScript API side, we're trying to make the JavaScript API smarter. So the 4x API is going to make it smarter and only request the data that's actually needed by the layer. But the 3x API doesn't do that right now. And so you end up actually asking for all of this attribute information, even though I'm only using 1, 2, 3, 4, 5, 6, 7, 8 attributes. So if I open the developer tab, let me clear this, and I'm just going to go back and toggle the visibility again, which will cause a requery. Couple things here. So this is the size of each of those query responses. One other thing that we changed in this last release of online is we now return binary data, protocol buffer format. That reduces the size of the query response somewhere between 30 and 300% depending on the data, versus JSON, which is what we returned before. So we've automatically made things faster in the last release of online for online hosted feature layers. But still, there's more that we can do. So this resulted, just to draw that map, in 1 megabyte of PBFs being returned. So what happens if we do what I said and remove the unneeded attributes? So this is a view. So I created that view by going to the hosted layer and created a new view layer. And it has this set view definition. So I can define the features, area of interest. Defining the features lets me set an attribute expression and only return those. Define an area of interest, let me set a polygon and it'll only return things in that polygon. But from the performance angle, defining the fields allows me to tailor this data. So I'm going to toggle all the fields off and find the ones that make this map. And these are the only ones that I want as part of this data set. Now if I go back, let me just clear it. And so we turn it back off and turn it back on. 267 kilobytes transferred. So we reduced the size of that initial view by almost an order of magnitude, more than a megabyte, just by removing the unneeded attributes for display. So this can make a pretty significant difference on the performance of your layer if you've got a lot of features drawn. I think in the context of this map, maybe it doesn't make that big a difference, but in some of the layers that Paul will show later, it can really add up. One more thing to call out. This is a bit under the hood, but Google penalizes you if you don't run HTTPS. So everybody, raise your hand if your organization is HTTPS only. Good. You definitely want that. And encourage everybody to switch that over. Because what Google and other browsers are going to do is to start penalizing sites for not being HTTPS. So this organization is not HTTPS, but if I switch this, and reload it, we may not actually see a noticeable difference, but now look at the protocol. It's not speedy or HTTP 1.1, it's HTTP 2. And HTTP 2 is the next generation network protocol for sending data over the internet. And it's faster. It's faster with a lot of connections and a lot of queries, which feature layers do. So it's definitely almost a must-have to be moving to HTTPS. In addition, outside of performance, Chrome is going to change this from being a secure button on an HTTPS site. They're going to flip it, and it'll say nothing if it's secure, and it'll say not secure in big red letters if it's not. So the writing's on the wall that we have to get all of our ArcGIS servers on HTTPS so that all of our organizations can be HTTPS. Okay.
If it's both, and I use HTTPS, it will work also?
If it's both?
Yeah, if it's not HTTPS only.
No, that's the problem. When you go HTTPS, then the browser won't load content that's not HTTPS. So you won't see things in your map. Okay. And with that,
So
turn it
over to
over
me?
to Paul.
All right. I'll talk to you guys a little bit about tile layers. So, all right. So, tile layers, as Jeremy said, come in two flavors, raster and vector. So raster tiles have been around for a long time. They perform really well, even for complex geometry. They're optimal if the data isn't changing. You can take a long time to cook tiles and regenerate them if your data is constantly changing. We do have, what I'll talk about in a minute, tiles from feature layers that automatically keep tiles up to date, basically, to minimize some of that. But if you're cooking, recooking your tiles, it can certainly take up time. So it's good for when things don't change very often. One of the big things, at some point, feature services can't draw everything on the map. I'm sure some of you have seen the little exclamation mark in the corner that tells you you're not seeing everything. At some point, it's just not practical to show everything. And that can lead to, especially at smaller scales, it may give a false impression of the data because you're not able to draw everything and see everything at scale. So one of the nice things about them is they inherently don't have data behind them, so they can be paired with feature layers to provide pop-up information. So you can still have a raster tile layer and pop-ups. Also, they're rasters. So if you're looking to put some imagery or gridded data up in ArcGIS Online, they work well for that too, which obviously vector tiles aren't going to do. Vector tiles themselves, one of the nice things, they support custom styling. They are fast and performant, even with large amounts of data. They cook faster. The tiles for vector tiles generate faster, so they take less time to recook. And they work really well offline, particularly with really large offline areas. With a raster tile layer, that base map can start to get pretty big into the gigs of space. Vector tile layers over large geographic areas will take up less space overall. So it's nice that way. And for all of us with really nice phones and tablets and HD displays, vector tile layers, because they're rendering vectors, stay sharp and crisp. Your labels don't get blurry as you zoom in on really high resolution displays. So those are kind of the two flavors. And within the raster tile world, we have what are called tiles from features. And so if you have a hosted feature layer in ArcGIS Online, you can actually publish a tile layer from that. And when you do that, you can optionally, by default it's on, but you can enable keep the data up to date. So the tiles, as the user pans around and views the map, the tiles get generated dynamically. If the underlying feature service gets edited, those tiles get removed and they'll get regenerated the next time a user looks at the map. So it's a way to get the performance of a tile layer and the benefits of a feature layer. And because they're being generated on the fly, you're only generating tiles when you need them. If you do need to cook tiles over a larger area, you can just go cook them manually yourself. And because it's backed by a feature layer, you also just get the pop-up for free. So if you add the tile layer to the map and click on the map, you'll get that feature layer's information. So, and if you're using it offline, like I said, you can generate all your tiles ahead of time if you want to, or you can let the system generate them as people view the data. And so it works really well for visualizing data sets that need to remain fast even when data is changing. So I'll look at a few examples. So that's kind of the general scope of where tile layers fit into the overall story here. But I'm going to pop over, and as Jeremy said, this is a feature service that I've published for Ontario, Canada. It's got a lot of layers, and if you look over in the bottom corner, it's a pretty big data set. So this isn't something we would traditionally show as a feature layer probably, because if we look into the map, you'll notice we instantly, even with some scale visibility set, we're exceeding the feature count. Let's just zoom in somewhere as close. We've made a lot of improvements to the feature layer. It is drawing reasonably fast, but you'll see it just this isn't the experience that you'd want for somebody viewing the map. It may work to bring it up quickly, but it's not what you'd want someone to see every time. So this type of data is a really good candidate to publish as a vector tile service, and that's actually what I've done in the next tab here. I've just used Pro. Just 1 second. I've used Pro to make a vector tile package, and what I've done is uploaded that in ArcGIS Online. And so now I have a hosted vector tile layer, and let's just go to the same area. And we should see all that come in faster. So you can instantly tell it's still a big data set, but that performance is noticeably faster than the feature layer. So that's vectors. They work really well as base maps. If you're using the Esri base maps, you can actually style layers. Anybody here use the new styler that we released to make fun base maps? It's on the developer site. There is a blog that I would encourage you guys, if you're interested, to go read. And it'll give you a link to the app, and you can actually take our Esri base maps, change the colors, tweak them. People have done lots of fun things, both internal and external. So it's a good way to have tailor that base map, even though you don't own it for specific maps. So you can match your colors and things like that. So I'm going to hop over to another example here where I've got another data set from Ontario. I happen to live in Ontario. I live in Ottawa, which is why I'm zooming to Ottawa. Got a feature layer here. This actually, it's performing pretty well. You notice that loaded quite fast. There's, in the entire data set, there's 700,000 features or so. It's not drawing 700,000 features, which is why we've got the little exclamation mark down there that says we didn't draw them all. So at this scale, we may not be getting a complete picture of the data because we're not drawing everything. It performs okay at this scale. It could be faster, but one of the things we could do is, from this feature layer, we could publish a hosted tile layer and actually use that tile layer for those smaller scales. So when the map is zoomed out, you could render the tiles. They're going to render sharp, fast. And as you zoom in, we could just set the scale dependencies and switch to the raster or to our feature layer. And you'll notice that because I've got pop-ups. And the same thing, this pop-up will look exactly the same whether you're clicking on it from the tile layer or from the feature layer in this particular case. So the way you make a hosted tile layer from a feature layer, if you go to the feature layers page, just go to publish. It'll bring up this window. We can give it a name. You scroll down. It's going to suggest a scale range. You don't have to go with that. Maybe I wanted it to display a little bit at higher scales. And I've got checked create tiles automatically. And so what that's going to do is, as the feature layer changes, it will remove the tiles that are outdated and regenerate them as needed. So I'm gonna click this and let this run, and then we're going to come back to it when we get into some of the cartography tips, and we'll walk through that example that I just talked about using both of those layers together to have a really fast layer that shows all the data at the kind of provincial scale, and then as we zoom in, we transition to use the feature layer. So I'll show that in just a
Could you
moment.
flip back over to mine? I just want to add one more point to what you were saying.
What number are you?
I don't know. Just pick one.
Not three.
Not 3. 1,
I think I'm
2,
4.
4.
There you go. Just to piggyback on what Paul was saying, this is a feature layer that has 180,000 points. It's voting precincts in the 2008 general election. and performs pretty well at this scale. And if I zoom in, you'll see those things crisp up and it performs really well. So at these scales, it's pretty good view. But if I start to zoom out, like at the country level, actually it will draw, but it'll take like 10 seconds or so, which, if your story is about, nation, what's the national view, then people aren't going to want to wait for those things to come in and draw. And so applying the same technique that Paul is going to demo with this data set is appropriate for lots of different data sets as well. And I wanted to add one more thing because I forgot something. For feature layers, there in the settings tab, there's a couple of sections here. Optimize layer drawing and manage spatial indices. So optimize layer drawing, I would say it's not quite there yet for polygon data, but for line data can work pretty well. But what this does is it will increase the speed of lines and polygons by generating multiple geometries at different scales. And then when we ask the server for a reduced resolution geometry, instead of it chunking away to do that for every feature every time we ask for it until it's cached, it will just pull from the one that's closest to that resolution that we're asking for to be generalized. Now, why I say it works, while there's still issues for polygons, we don't quite have it in sync so that if you have coincident polygons, like let's say zip codes, when you zoom out and if you take the outlines off, you will still see some slivers, and that's not very good from a cartographic standpoint. So we're going to keep working on that to make it better. But if you've got linear features or polygons that aren't coincident, then it is a pretty good option. And then even if you turn that on, those get updated, right, on edit? Yeah, even when you turn that on, sorry, mental block. Even when you edit, all of those geometries will get updated. So this is a one-time thing. Now, I said it'll improve the performance of initial view until it gets cached. Because we always send things to the feature service that can be cached at different tiers, as soon as it's cached, this isn't really going to come into play. But it's that initial view of a data set that will benefit from optimizing that layer drawing. But I don't recommend it for polygons that touch until we fix it. Then the last thing is we introduce this manage spatial indices. And there's a couple of reasons you might want to use this. If you started your feature service in a particular area and then you grew your data, you collected data outside, at some point you might need to rebuild those spatial indices. Or if you publish a big, very large data set several years ago, we unfortunately had some issues around the spatial index not getting created correctly, and so you might see some things that need to be rebuilt to fix problems that we had originally. So what I would say is most likely you don't need to use this at all. But if you've got a big data set that even when zoomed into large scales, at the local level, queries seem to be really crawling, taking like 5-10 seconds to come back or to draw, then come over to the layer and just rebuild the index and see if that improves it. Okay.
Cool. 3, please. So let's talk about scene layers. How many of you have tried out scene layers or published your own scene layers to ArcGIS Online? Yeah, got a few. Still kind of new, so it's growing. So I'm just going to talk about a little bit about how you can create these and how to use them. So what are scene layers? If you're not really familiar with them, they're helpful for visualizing large data sets of 2D and 3D features. In ArcGIS Online and Portal, we have 4 types of scene layers. And I have corresponding images to all these types on the right-hand side. Um, First up, we'll talk about point scene layers. So yeah, these are great for visualizing a large amount of points in that image, and I'm going to show you a quick demo of that soon, is 80,000 points around the world looking at world population. And I can use 2D or 3D symbols with them. And these points, they only have an X and a Y. So you don't have to think, I need to have something that has an X, Y, and Z. You can use point features that just have an X and a Y. The next up are 3D object scene layers. And you can use these to represent such things as buildings. Like in that image, we're looking at buildings within New York City. But you could also use them for looking at creating geological bodies and looking at them in subsurface data. Next up, we have integrated mesh scene layers. And in that image to the right of it, you're looking at buildings and trees and terrain that were all captured by drone data, and then we use drone to map to kind of stitch that data together to create this one layer of all those both like man-made and natural features into this one scene layer. And so it's great and I'll show you a quick demo of that too, for visualizing those kind of features. And finally, we have point cloud scene layers, and these are great for looking at last data or LiDAR data that you had, and you publish them to ArcGIS Online or your portal, and you can use smart mapping to style them to look at like RGB or classification, intensity, or elevation. So you can style them within the scene viewer as well. And you can use these scenes in both local and global scenes. So like I have a global data set of those points around the world, or I could look at them in a local scene of buildings just within New York City with a fixed extent. So you don't have to always have it in WGS84. You could use it in your kind of projected coordinate system for your region. And with some of these, with point and 3D object and point cloud scene layers, you can use smart mapping in the scene viewer to visualize these layers. So something similar to what Paul talked about, you can have like tiles with with an associated feature layer. You can have scene layers with an associated feature layer. And so you can publish these to ArcGIS Online in Portal. So if you have a large point data set, I would recommend you publishing a point scene layer, because you then are using those 3D tiles to get an efficient, fast visualization of those points. If you wanted to visualize complex multi-patch features, you wouldn't be using the feature layer. You'd want to publish it as a scene layer and bring that into the scene viewer to look at your buildings. And we leverage that feature layer that's behind that scene layer. So similar to pulling up a pop-up on that tile layer, you can use the pop-up that you defined on that feature layer, and the scene layer will pull that. The scene viewer will reference that pop-up in the feature layer and display it in the scene layer. And you can use those attributes within the scene layers to visualize these features, so for different smart mapping styles. And another great thing that you can do with these scene layers is that you can rebuild them, because let's say you have a group of field workers out collecting with collector, and they're collecting trees within your your region, and there's a large point data set, and you're displaying them in a city scene, and you added in updated attributes or you added new trees. You can go ahead and rebuild that scene layer and pick up those changes. So you're not just getting those static tiles. And the same thing if you had buildings, let's say, and you added a proposed building that got approved into the master data set, you could use the append and update on the feature layer and rebuild the scene layer. You can also publish these scene layers from scene layer packages. So in this case, you can publish point, 3D object, integrated mesh, and point cloud scene layers from these scene layer packages. You can create these scene layer packages in ArcGIS Pro, and you can upload them using the new multi-part upload in online if they're very large, or you could also use the share package tool. And you can still use smart mapping on the point and 3D object and point cloud scene layers that you publish from these scene layer packages. They still have pop-ups that you've defined, let's say in ArcGIS Pro, before you built the package, and we'll honor that pop-up definition. But one thing is, because it's coming from this scene layer package, it's not really tied to a feature layer in this case that could be dynamic. It's more of a static cache, so you won't see this rebuilding option. So let's go ahead and look at some of these scene layers quickly and some of the ways that you can visualize them. So starting off, here are those points around 80,000 points around the world, and we pulled them out from a grid, and we have the population that was within that grid as an attribute value. So I can just go into that layer. I can pick that population attribute. We're seeing this large data set updating on the fly, and I can now use 3D symbols, like this counts in the mount style. And I can go ahead and update the sliders. And you see that the large data set is updating, and you can see it's all streaming into the scene viewer within this web scene. And that's just a simple basic one that you can just, to look at these points, you can publish your own 3D symbols to ArcGIS Align as well and use them with your point feature layers or point scene layers. For you, those of you who caught the plenary, Jennifer Bell demoed looking at smart mapping with a 3D object scene layer at New York City and looking at the energy usage of these buildings. So here I have the 3D object scene layer that I published with an associated feature layer. I can go in and look at this layer, and I'm going to go and pick the energy score attribute, and right away all of my buildings have been styled. I can be using buildings that have a realistic look with textures, and I can apply the smart mapping on top of those textures together, or I can remove the textures completely within the scene viewer. I don't have to rebuild this multi-patch data set without textures, so I can use this smart mapping style with textured buildings and untextured ones. And we're still getting great performance with the sliders against this data set. So as I move the sliders up and down, you can see that the buildings are updating. And the great thing about it too is I'm using the feature layer behind the scene to drive the pop-up. So here I have a pop-up that I wrote an arcade expression that kind of breaks down the energy score, which is a numeric value, into something that's readable, like this building has an energy score of A, which makes more understanding to the general population than one that has like a score of 78, 79. What range does that actually fall into? And as I update the pop-up on that feature layer, the scene layer will automatically pick it up, and you'll see it in the scene viewer. Next one is, let's look at that point cloud scene layer. I have two examples of this just to give an idea. I have one showing a massive number of points on the coast of California. There was a massive landslide, and I packaged all these LiDAR points collected by the USGS and published it to ArcGIS Online. And here we're streaming in millions of dense points. It almost looks like I have a raster draped over the terrain that Esri provides, but this is actually just a demo data set of millions of points coming in this point cloud scene layer. But you can also have attributes within these points. So let's go ahead and go over to Denver, and let's look at the stadium there. Here I have a point cloud scene layer with RGB values, classification, intensity, and elevation. And I can use those attributes to go ahead and style it. So here I'm using classification class style with intensity. So if I remove the intensity, you see I kind of lose that high level detail that we saw within this scene. If I can go ahead and I can leverage the RGB values, so now we get a more realistic looking scene like the one beforehand. And if we wanted to, we can look at the elevation. And just like with the class one, I can go ahead and look at with the intensity to get a little bit more detail. And the final scene layer I want to show you is a sample that we've gotten from one of our partners, Bricon, and we're looking at Half Dome in Yosemite. And you see how fast that data streamed in here. And the one thing that we're working with the 4X API is continually improving how we're loading scene layers in. So we want to keep continually improving the performance of these massive scene layers. And so this is an integrated mesh scene layer that's covering all of Yosemite. There's no smart mapping and styling with the integrated mesh one. It's purely for visualizing right now these realistic features, like we can kind of zoom on in and look at like trees and the detail on the side of the dome. So this isn't terrain, this is scene layer kind of already draped over the terrain.
Russ, is there any tips for scenes that are slow?
So just similarly to what Jeremy recommended with the feature layers. You get more performance, a better performance when you have just the attributes that you need within your scene layer. So you don't want to have those unused attributes within your scene layer because you want to improve the performance. We cache our scene layers too. So after you've viewed it the first time within your scene and you navigate around and go back to that area of interest that you had originally, you'll see that because of the way that we kind of cache that experience, that the performance will be great for navigating around the scene. Cool.
I would say the same thing about HTTPS. It's probably the most important for these types of layers because the way these layers request data, they make lots and lots of connections, and that not having HTTP2 really penalizes you. So we had like some data sets like that would draw 20 seconds faster just by going HTTPS.
Yes. Yeah. Cool. So yeah, that's just some little tips and tricks on visualizing these scene layers and how to publish them and their different data sources.
Yeah, the other thing I'll just say about on the 3D side is it's a little bit easier. There's not as many options that you need to think of, and they're able to. They have built in a lot of degradation in the actual viewing of the 3D content as based on like how detailed the object is that's being drawn. That's sort of like baked in. So I think they're seen on the 3D side, they're actually farther along, so you don't have to think as much about the different types. Although the things that Russ and I pointed out about HTTPS and removing unneeded attributes does make a difference.
All right. So now I'm going to talk about visualization strategies. And Russ, Jeremy, and Paul just showed us a lot of great things you can do to show a lot of data, a lot of performant data. We still want to think about how we're visualizing the data to actually provide stories for our users who are reading our maps. So we're going to go through 4 quick visualization strategies about how to think about visualizing your maps. Okay. So strategy number 1 is displaying the data that is important. So we went through this a little bit on the performance side where Jeremy showed how to remove some of the attributes with hosted feature layer views. But we want to make sure that we're focusing the audience on the important stuff in the map. So using filters to hide data that isn't relevant, using definitions and hosted feature layer views to limit what the user sees. So that's either by features or the attributes that they're seeing. Making sure that you're setting good default extents and using bookmarks so that users are navigating to the areas in your web application that has the content you want them to see. And then also using time sliders where appropriate. Time sliders are really great for showing sections of times of data for time-enabled data. So it's always a great option to use. So for a quick demo, I'm going to show the... Oh. This always happens.
Kelly has the most problems with her laptop.
I do. That's not a lie.
There's the PowerPoint. Don't touch it. She needs to get out of the PowerPoint.
I need to.
Alt tab, maybe?
Yeah. Like I wasn't doing anything ridiculous there. Okay.
Kelly's first time to presenting to Jack. Can I tell that story, Kelly?
Yeah, you can tell that story.
While you're getting ready.
Yeah, okay.
She had just got a new laptop and went to plug in, and the monitor didn't recognize it. So it was like all squiggly. And so then when you presented to Jack for the UC briefings, it's like he's on a time crunch. So there was no like resetting it. So then Kelly borrowed Sentha's, another person on the online team's laptop, has one like Paul's. With a weird trackpad that Kelly had never used before. Mm-hmm. So all she could do was right-click on the screen every time she touched something.
Duplicate.
It was one of her favorite times, I think.
Yeah, it was. Okay. Kind of like this. Thanks. Okay, great. Okay, so I'm going to show the earthquakes that we've had in 2017. This is a great data set that you can really easily access on the USGS website. As you can see, we've got quite a lot of data in here. there's about 17,000 features in here. And you can see a lot of that we've had quite a few earthquakes. What I want to do is create a map that's easy to understand where the large earthquakes are or have happened, and guide my users to find them. So what I'm going to do is go ahead and filter out the data. So I'm only seeing the larger magnitude earthquakes by setting a filter. So I'm going to go find the magnitude attribute is at least, and I'm going to make it at least magnitude of 6.0. I'll apply the filter, and you can see it's easier now to understand where the large earthquakes are. And I've already set, I had already set the the graduated symbols so you can understand where the big earthquakes are and where they aren't. And then what I can do is go ahead and make some bookmarks for areas where I actually want to take a look at the larger sets of earthquakes. So I'll add a bookmark here for Mexico. And then over Southeast Asia. Then what I need to do is find a good default extent for what I want my users to see when they open an application. So I think that this is good to get an overall idea of where the map is. So I can go ahead and save the map. And then I can share it in an application. This way my users can really easily find the data that I'm looking for them to see within the application. I'll try and go back to the... Oh. It's all right, you guys are doing the next demos. Okay, so strategy number 2, we're going to visualize patterns of large data sets using aggregation. So this really helps to get your data together into easily understandable sets of data. And Jeremy's going to show us a little bit more about this.
Okay. Switch base maps so you guys can see. Okay. So these are all the trees in Beverly Hills, and sometimes it's better to just, like Kelly said, visually to aggregate the data, display its not the raw data, but some aggregated view to give people a better idea of what's going on. That's good for the user understanding it, and then it's also good for performance because you're reducing the amount of features that are being drawn. So here's all the trees in Beverly Hills. They all have a common name like Hollyoak or and so on. And what if I wanted to turn on the block group? So that would be this blue line here. These are the blocks in Beverly Hills, and I can go ahead, since these are just the street trees. An interesting visualization would be to just aggregate to that block, to that blue line there, to see what is the most common type of feature. So I can go to the analysis tools, summarize data, aggregate points, and here I could aggregate if I didn't have this. Let's switch this here. Sorry. Yeah, this is blocks. If I didn't have the census blocks, the polygon layer I'd want to aggregate to, I could aggregate to a square or a hexagon, and it would generate those for me. And then a nice feature is to be the ability to group by the common tree name and add the minority majority. That's going to tell you how big, what is the most common type of tree in that polygon. So in the interest of time, I've already ran that, and we get a view like this. It's much easier to understand this view. We see the colored red there. It's the most common type of tree is the London plane, southern magnolia in pink, American elm in orange. And you see a city like Beverly Hills is a very planned city, so it looks like they planned it that way. So not only is this much faster to load because you've aggregated to a smaller number of features, it presents a more appealing picture to the user. And then you can always set scale dependency so that you zoom in and you can see the actual features.
All right. That's a nice segue into our next strategy, which is using the visible scale range to display information when relevant. And Paul's going to go into this a little bit more, but it's really about using that scale range to show the data that you need to show at the appropriate levels.
Yep. So we've talked a lot about optimizing how we query data to reduce the size of it. I'd argue that a slightly better approach is not querying at all if you don't need to. So you remember the raster tile layer that I started with, and in the previous demo, I've added that to the map, and just for reference, in a baseline, here's our feature layer drawing at the province scale. It was pretty fast. Now that we've got the raster tile layer, you notice it's faster. And so what I've done here quickly is gone into the feature layer. I've set a visible range on that, as well as the map, the tile layer. So basically, at the more zoomed out scales, the tile layer will be used to draw, and I can still click. So if I wanted to see a pop-up here, I can get my pop-up, no problem. So basically, they'll switch once I get it in zoomed far enough. So if I come in and let's go back to Ottawa. Wait. So we're still rendering. You can see that the raster tile layers are still being rendered because it's not grayed out. The feature layers is still outside that scale dependency. And so when we switch one more level, we're back to the feature service. And we're at a scale now where the feature service performs fairly well. We could probably still stretch that a little further to make it really snappy. But by using that tiled layer from a feature layer, you can kind of pair them together to optimize how you draw and set up that map. So to the user, it looks exactly the same. The data is the same. They can click on it just like they would, regardless of the layer type. But what you've created in the process is a faster experience.
All right. And there's one more strategy, which is clustering points into groups. I don't think we're going to demo.
I think we're out of time.
We're out of time to demo it, but there's some great tools with clustering.
And we can just open up for questions.
Yep.
John?
I'd like to go back to your feature collection that you mentioned up front. I understood you to say that if you load in a CSV file, it becomes a feature collection, and there really should only be 4,000 points in the ballpark. Thinking about that demo that the query, the client-side query, that they loaded up 100 and some odd thousand CSV features. Was that a feature collection that just took advantage?
That was a CSV layer, so it loaded the CSV, but is similar to the feature collection. So the 4X API can handle a lot more local data and does have the ability to do client-side queries on top of that local data. So that may be more of a strategy in a 4X JavaScript API app.
So there's a distinction in between a CSV layer and a feature collection. They're
Yeah.
completely different layers.
They are completely different layers. Yeah.
Thank you.
So if I publish a hosted feature service out of Portal, does that mirror all the capabilities of the latest and greatest in ArcGIS online, assuming I have the latest version of Portal?
Well, not exactly. There's a couple of things that aren't there. So when publishing to your enterprise hosted feature layer, at 10.6.1, that will enable WebGL on the map viewer and the apps that support WebGL today, where that did not at 10.6. 10.6.1 does not have the protocol buffer format, that binary format that I was talking about. That does save some size. That's tentatively planned for 10.7. They're trying desperately to get it in there. Have to see how it goes during the release cycle. Then the other thing, which we didn't really talk about, but that hosted feature layers and online give you, is we have an extra level of caching, so that the first query might be slow, but after that, the query should be fast, no matter where you are, public data, private data, and so on. That is not in 10.7. They're working towards that, but that's probably going to be the post 10.7 release before enterprise gets that.
Like 10.7, you mean 10.7 portal?
10.7 portal, yeah.
Okay.
Yeah. So eventually they'll be the same, but it's just going to take a little bit longer.
So one other quick question is, if you're hosting services out of portal on Big Data Store, via the Big Data Store, are you guys planning to like support feature service sync on it so we can actually pull down like map JSON to like publish offline, like to use it for offline use?
For big data, I don't know the answer to that question. For publishing, enabling sync on Big Data Store, I think it'd be best to go down to the
big data guys.
big data island. Yeah.
Thanks.
I have a project that predates Portal, and so in our legacy system, we've got an Oracle backend with like billions of data points. So we publish that to the standalone ArcGIS server, and it's unfederated from our Portal. And so we've added those map services as items in Portal. And so when we make apps, it's kind of slow because it goes from Portal, queries the external ArcGIS server, into Oracle and back. So do you have strategies for improving performance in that setup? Or another question, which is what I really want to do, is how do I get like a giant legacy Oracle database into ArcGIS Enterprise?
So the question is, how do you get a legacy Oracle database into enterprise or into online?
Well, we have an offline on-premise portal. So I've got a big data store, I've got portal, I've got, like, how do I get the giant existing data set in there?
I think that would just be a publishing process, like get the data out and publish it in. I thought you were going to talk about if you've got an on-premise portal that you use for your system of record, and you want to build public apps on top of online, so that online takes the hit on the terms of the load. Portal and online have support for collaboration, so you can set up collaboration from your enterprise system. It'll replicate the data in online and sync updates at your interval of choosing, and then you can use online for the data that's meant to be public and pushed out, and you don't have to worry about acquiring servers to support that. One more, and then I think we're over.
For large data sets that require editing, are performance better hosted or better via
Large data sets that need to support editing, I think it should be about the same. We didn't say the most important thing, Kelly.
Yeah.
Which is don't share a editable layer to the public, because editable layers do not get feature generalization. There's two reasons. One is it'll be slow, and editable layers don't get feature generalization. So you're always going to be pulling the most detailed geometry down, which will definitely be slow. And two, unless you mean for the public to edit it, don't make it editable, because they're gonna mess with you. And if you do it in online, because of the scaling part, we'll come and find you if you do it. It'll be Kelly. She'll go get a phone call from her, and we're gonna turn off editing for you.
map services better about getting it on the server, query only, hosted, query only, but they did not get capability to look like fastest performance.
You don't need edit capabilities? I don't know the detailed answer to that. I would assume it would be the same.
Between SDE and S and ArcGIS Online.
Wow. All portal, yeah. The big data store is probably the fastest at query. So that would probably be the fastest. But in general, it should be pretty similar. All right, thank you, everyone.